Hello, today we will be doing the analytical chemistry. This is the syllabus of 2021 examination. What is analytical chemistry? This is the branch of chemistry which deals with the experimental study of substances both by qualitative as well as quantitative methods. Other definitions. What is analysis? Analysis is the determination of the chemical components in a given sample. There are two types of analysis. One is qualitative analysis, another is quantitative analysis. What is qualitative analysis? It involves the identification of the unknown substances. What is quantitative analysis? Involves the determination of composition of a mixture and identification of unknown substance with the help of reagents. Now, what are reagents? Reagents are substances which react with other substances. Now, alkalis are important laboratory reagents. Now, these are generally used as laboratory reagent, and most commonly used alkalis are sodium hydroxide, which is the strong alkali, and ammonium hydroxide, which is the weak alkali. Both these alkalis give the characteristic tests with different metal cations, and thus the cations can be identified. There are the charts of colored of salts and solutions. If you see the salts of representative elements, that is group 1, 2, then 13 to 17. These are generally colorless. Salts of transition elements like group 3 to 12 as well as lanthanides and actinides are generally colored. Different colors of salt help in their identification during quantitative analysis. You can see the cations and the respective colors. Here you can see the anions, you can see the respective colors. You don't have to learn the chart this way. Every day if you practice different salts and write the reactions, you will automatically learn this. These are the colorless cations and anions, as I told you. For representative elements, group 1, 2, 13 to 17, generally colorless. There are some like lead, zinc, these are also colorless, and anions also. Action of alkali on metal cations results in the formation of their hydroxides, which appear as precipitates. Now, precipitation is the process of formation of an insoluble solid when solutions are mixed. Now, what is the action of sodium hydroxide solution? Sodium hydroxide is mainly used for precipitation of insoluble hydroxide from metallic salt solution. Formation and color of the precipitate helps in identification of metal ion. Now you can see here calcium salt, when reacts with caustic soda, it gives the calcium hydroxide precipitate, which is white precipitate, and you know this is the representative element group. So this is white, and this is in excess alkali, that is in excess sodium hydroxide, this is sparingly soluble. Now, ferrous salts, in the previous chart we had shown that the ferrous will give some green color, ferric will give yellow, ferrous will give light green. So, you see here ferrous sulfate is pale green, caustic soda, and ferrous hydroxide you get, it is a green shade again, that is dirty green gelatinous precipitate. It is also insoluble in the excess alkali. Now, for ferric salt you will get the yellow color, and when it gives you the precipitate of ferric hydroxide, then also it gives the reddish brown precipitate, and you get insoluble in excess alkali. Now here you are getting all insoluble. Now if you go for copper sulfate, you will get pale copper hydroxide, pale blue copper hydroxide precipitate, which is insoluble in excess alkali. Then zinc salts, they also give the white gelatinous precipitate, and for sodium zincate, this is there. Now in this white gelatinous precipitate with excess of NaOH, PPT dissolved, that is zinc hydroxide dissolves. With excess this, it is dissolved. Now what is that say? Some precipitated metal hydroxides dissolve in excess sodium hydroxide. So this is the, in excess sodium hydroxide you get the complex salt, that is sodium zincate. So what is happening over here? Zinc sulfate gives you first white gelatinous precipitate. Now when you add more sodium hydroxide, you get sodium zincate, which is the complex salt and it is soluble. Now come to lead. Lead nitrate is also colorless, gives you white PPT, which is lead hydroxide, which is chalky white. Now with excess sodium hydroxide, this gives you sodium plumbite. Now this white precipitate of lead hydroxide is readily soluble in acetic acid. Now how do you differentiate this lead and zinc salt? Both are white. Now in first case, zinc will give you white gelatinous precipitate, lead will give you chalky white precipitate. Now both are soluble. Now you can check whether these hydroxides are soluble in acetic acid or not. Now white precipitate of lead hydroxide will be soluble in acetic acid. So this will give you one differentiation between lead hydroxide and zinc hydroxide. If you are unable to understand what do you mean by gelatinous and chalky, you can check with the acetic acid. Next is ammonium chloride and ammonium sulfate. They also can react with sodium hydroxide. They will give you ammonia gas will be evolved, and the same equation will be taking place with potassium hydroxide solution. Next go for the action of ammonium hydroxide solution. Now ammonium hydroxide can be used in variety of applications in qualitative analysis. These all are qualitative analysis. First is for precipitation of metal cation. We'll see. Now here all precipitation had been done. Okay. Then for formation of complex salt. Complex salt means you will be getting something soluble over here. So here you are getting the complex salt. See this one. Tetramine copper sulfate, tetramine copper hydroxide, these all are complex salt. And for making medium weakly basic, here it is not given. You might have seen there are several reactions you will be seeing when the reaction is taking out in basic medium. Okay. So now first you see for calcium salt. If you use calcium salt with sodium hydroxide, you will be getting no precipitation because concentration of hydroxyl ions from the ionization of NH4OH is very low because it is the weak base or weak alkali. So it cannot precipitate the hydroxide of the calcium. For case of the iron, you see the colors are almost same. You will get dirty green precipitate insoluble in excess, reddish brown precipitate for ferric insoluble in excess, then reddish brown precipitate in case of ferric sulfate, again insoluble you are getting. In case of copper sulfate, you will first get the pale blue precipitate. With this excess of NH4OH, that is ammonium hydroxide, this precipitate will dissolve. See the reaction what is happening. You are getting tetramine copper sulfate. Okay. Now copper hydroxide will work with NH4OH, so you are getting tetramine copper hydroxide. So these both the salts form deep blue solution. This reaction is the characteristic property of copper 2+ ion and generally used for detection or in qualitative analysis. So here this is the formation of complex salt. Now for zinc. Zinc salts also first give you white gelatinous precipitate. This zinc salt will be dissolved in ammonium hydroxide. Now in ammonium hydroxide it forms tetramine zinc sulfate, which is the colorless solution. Both the equations are shown like as it shown in copper sulfate. So it is soluble in excess NH4OH. Now for lead nitrate in NH4OH you can get white precipitate of lead hydroxide. It is insoluble in excess. Now if you want to differentiate between zinc and lead salt, you can use excess ammonium hydroxide also, even if you get lead hydroxide in with sodium hydroxide, means you got reaction of zinc sulfate and sodium hydroxide got zinc hydroxide, and for lead nitrate you got lead hydroxide. If you want to differentiate these two hydroxides, you can add ammonium hydroxide in zinc hydroxide. You will get first case that zinc hydroxide will be dissolved to give tetramine zinc hydrate, whereas lead hydroxide will not dissolve in excess ammonium hydroxide. So read this part very carefully and make the differentiation table of your own. Action of alkalis on certain metals. Now what is happening over here? Like metals like zinc, aluminium and lead react with hot concentrated alkalis like sodium hydroxide and potassium hydroxide to give the soluble salt and liberate hydrogen. All these reactions had been done by you in the hydrogen chapter in class 8 and class 9. So you can recollect this and please write these equations on your own again and balance compulsorily. Then is action of alkalis on metal oxides. You see this amphoteric oxide or hydroxide. What are amphoteric oxides? Which are exhibiting dual character, that is they show acidic as well as basic character. Now this zinc oxide reacts with sodium hydroxide to give sodium zincate and water. Zinc hydroxide against sodium hydroxide. Likewise all the reactions with zinc salts and sodium or potassium hydroxide are shown. Same for aluminium oxide, aluminium hydroxide, aluminium hydroxide with NaOH and KOH. And we are getting corresponding meta-aluminates. For lead oxide also PPO, you see the colors, this color you should remember, and these will get sodium plumbite, potassium plumbite, etc. So this is again the relation given where you are getting this equation. Sodium oxide reacts with water to give sodium hydroxide. So this is the alkali. So sodium oxide is alkaline oxide. These metal oxides and hydroxides generally neutralize the acids but do not react with the bases. Now sodium oxide reacts with HCl to give NaCl. NaOH reacts with HCl to give NaCl. But in case of zinc oxide or aluminium oxide or lead oxide, they react both with acid as well as alkali or bases. Like zinc oxide, when react with HCl, gives you zinc chloride and water. Zinc hydroxide, when react with HCl, gives you zinc chloride and water. Now in case of zinc oxide and hydroxide, when it react with the base, concentrated base, it gives you sodium zincate and water. So amphoteric oxides and hydroxides are those compounds which react with both acids and alkalis to form salt and water. This is the end of the chapter. Thank you.